All right, in this example, we have a 4-state legislature with 100 seats, and the states have the following populations. State 948, 749, 649, and 7654. So we want to use Webster's method to apportion the seats. So we first need the standard divisor. The sum of all of those is, again, 10,000 divided by the number of seats, which is 100. So the standard divisor is 100, and the standard quotas are, since we're just dividing by 100, 9.48, 7.49, 6.49, and 76.54. So Webster rounds based on the arithmetic mean, so general rounding. So this would be 9, 7, 6, and 77. And that does not add up to 100. That will give us just 99. So we end up needing one more, which means I'm going to need a modified divisor and modified quotas. Now, you can see it's not going to have to change much, right? So the question is, which one of those is going to fall over first, right? So what I can do is, I don't want to change it very much. I tried a couple, and the one that I found that worked for a modified divisor was 99.93. And so what happened is I went through and divided each quota when I did 948 divided by 99.93, I got 9.49. When I did 749 divided by 99.93, I got 7.5. And 649 divided by 99.93 was still 6.49. And 76.54 was 76.59. And then when I round those based on the 0.5 or above, we have 9, 8, 6, and 77. And that will do it. And that will get our rounding, our apportionment using Webster's method. Now, a 4-state legislature, so same problem. Now we want the Hill-Huntington method. They use the geometric mean in order to round. So this one starts out the same as the previous one did. I'll just put those notes up here. The standard divisor is 100. And then the standard quotas are 9.48, 7.49, 6.49, and then 76.54. And rounding here is based on the geometric mean. So what I did was just create a list of the geometric mean. For each one. So the square root of 9 times 10 is 9.49. And square root of 7 times 8 is 7.48. The square root of 6 times 7 is 6.48. And the square root of 76 times 77 is 76.50. And the rule of thumb is when you compare the quota, if the quota is greater than or equal to the geometric mean, you're going to round it up. So first one will round down to 9, but the second one will round up to 8. This third one, it's greater also, will round up to 7, and then this last one, being greater as well, will round up to 77. So let's see what happens when we add all of those together. We should get 101. That's one too many seats. So I have to change my modified divisor. Again, I only need one seat to sort of fall over and not round up anymore. And not sure which one will do it first, just by looking at it. So I need a new modified divisor. The one that I found that worked was 100.1. It's just a trial and error thing. You have to try till you find one that works. And then the modified quotas that went with them were 9.47, 7.48, 6.48, and 76.46. And so you compare the quota. If the quota is greater than or equal to the geometric mean, round it up. But so this is less than that, so it's going to be 9. These are equal, so I can round that up to 8. Equal, so I'll round that up to 7. And here the quota is less than, so I'll round it down to 76. And I lost my one seat, so there's my apportionment.